We have our speaker, Tom Korn, Senior Vice President, Security Products, VMware.
Thank you. Thank you for joining us. And we're thrilled there's so much interest in this topic, so thank you. You know, VMware, this is going to be looking at this topic from a slightly different perspective. VMware it's not a security products company. We're ultimately building the fabric of the cloud and some of the fabric of mobility. So what we'll present in this session, focused mostly on both private and public cloud, and in the subsequent session that John Britton will do that focuses on mobility and looking at it from a user perspective, is really a similar angle, which is how we might use the fabric of the cloud and the mobility to take a very different perspective and very different take and a very different model on security. I'll also be talking about some of the new things that we're starting to design and build and work on, and share some of those with you over the course of the talk. Actually, there's some members of the team, of my team, that are here today who are some of the members building these new products. And for those of you who've ever had an opportunity to build a new application, you often refer to new applications as your baby. You take great pride in it. You're trying to usher this thing into reality. And it made me think about whether, as you think about your first baby, whether that might be an interesting analogy or metaphor for some of the things that we struggle with in security. There's an old expression that your first child's made of glass, and your second child is made of wood, and your third child is made of concrete. And I remember my first child. It truly was an experience of thinking about it as glass. And I think about that process, that development process that we went through from the planning phase to development to functional test and ultimately to general availability. But it wasn't quite overwhelming until day 2 operations. That definitely set a new bar. Here we had this thing, this overwhelming feeling we needed to protect from anything that might go wrong. It came with no instruction manual, no user guide, no threat model. And we're struggling to figure out how to protect this thing. And this is where the trouble starts, because then you start to study all the possible threats that might happen, all the bad things that might occur. You start reading WebMD and Dr. Spock, and it seems like every article that you read is about things that can go wrong, and you start to get in a bit of a panic, and you're talking to family members, and you're calling your physician, who in the beginning is actually quite patient with you, but at some point there's an intervention, and he says, you need to stop reading WebMD, and I need you to put down Dr. Spock. We need to restore the sanity. You can't just focus on all the threats. You're going to drive yourself nuts, and you're going to drive me nuts. Here's what I need you to do. I need you to focus on your child. I need you to focus on ultimately what you're trying to protect here. You're not chasing every threat that can go wrong. And I need you to start by creating a safe environment for your child. And that begins by understanding the needs of your child, what that child needs access to, who needs access to your child. I mean, think about it. We do this in the hospital. If you consider where we put babies when they're first delivered in this nursery, we keep them together in a room. Why do we keep them in sort of its own room? Because the whole governance model of who should get access to these babies and not, and who should be able to take out a baby, and what might look weird around a room full of babies is a very sort of simple, sort of straightforward process. Now, imagine if we placed babies wherever we had spare room in the hospital, just sort of distributed these babies around the place. Imagine the difficulty, the challenge of controlling access, of sort of the analytics of determining whether that was weird for some interaction with one of these babies. It'd be a nightmare. You'd never do this. And you're going to go through the same practice at home. You're going to think about what your baby needs access to and not needs access to. In the beginning, that's relatively simple. It will get more complex as your child starts to grow and crawl and walk, and then you need to think about child-proofing your home, and it's about thinking about what your child needs access to and get rid of everything else. Next is about this incessant chasing of all these threats and when do you know or detect that something is wrong. Again, you need to start by focusing on your child, okay? You need to understand what's normal for your child because some kids cry a lot and some kids don't. And some kids are hot and some kids are cold. And some kids eat a lot and some kids don't. You need to call me when things change. That's when you need to take notice. And by the way, in the hospital, they're going through the same thing. There was a time in medical practice was the diagnosis was a decision tree that you went through, and at the end of it, regardless of the patient, you sort of decided what was wrong. And over time, medicine evolved where they started to study the individual patient more and more because they found that early detection of things was much easier when you understand what was normal for the patient. So was designing remedies that weren't going to harm the patient. All right. Your critical application is your baby that you're trying to protect. Now, we don't have our critical application sitting in its own nursery with a very simple and yet granular governance model around it. The last time our applications looked like a nursery is when you had monolithic stacks, when you had entire applications on a single piece of hardware or in a single set of hardware dedicated for this. And when you had that model, you had a very, like the nursery example, you had an access point, a single access point that had two very critical properties. One was nothing in the rest of that hospital or in the rest of those buildings could get access to that asset without passing through a single inspection point. And so you knew with trust, with integrity, that you will have an opportunity to inspect that. The second thing is you had a single tenant inside, a single application inside that. So the access policy and the analytics to determine what's normal and what's not normal was very, very simple to do. But that's not what an application looks like today. An application is a distributed system. It's web servers talking to app servers, database servers, storage servers. It's containers and composed services, right? It's distributed babies. And we have hundreds of these. We have thousands of these all commingled on a common infrastructure. And that has led to relatively flat network architectures. And so in this world, an application is a set of systems that are occupying different rooms and parts of rooms and different wings of the hospital all interacting together. And that creates a very, very different model for how we have to think about protecting it. In fact, it introduces massive complexity and difficulty in containing threat models. Because when we go to implement and enforce security policy doesn't really have anything to do with networks and servers. It has to do with users and applications and data. But those aren't the handles we have in this model. The handles we have are physical assets. We certainly know the egress point to the data center. And then beyond that, and moving inside, the only way we can contain things is by thinking in terms of attributes of physical systems. My production systems versus my development, my web servers versus my app servers, and in this model, there are most certainly logical security policies that you could implement here, like production shouldn't talk to development, or web servers should probably never talk to storage servers, or app servers should only talk to database servers over certain ports and protocols. But at some level, this is security theater. Because this does absolutely nothing to contain lateral movement, and this does absolutely nothing to help us align controls to what you're ultimately protecting. If anything passes our perimeter, and things will, it's such a broad attack surface. There are so many ways that something can be introduced inside the environment. It's just too porous. If anything gets in, we happen to have, in this model, commingled assets from many applications inside every one of those physical segments that we've created. So if something falls in those app servers, I have freedom of movement to all the other app servers. And then I can simply use the applications themselves to hop across these segments. This is how lateral movement occurs. This model has done nothing to help us with the lateral propagation or the lateral movement. But it introduces an even bigger problem, which is complexity. Consider this. First of all, if you're going to move controls inside, where would you put them? Because you don't have an egress point. I mean, you're going to put them on every corner and every hallway. Right? How are you going to have a place that you know you can inspect things? Now, you're going to end up placing a control, for example, in front of a segment, And it has to end up having the policies for every application represented behind its boundaries. Now, that could be hundreds of applications. That's why a firewall in front of a segment has 30,000 rules in it. And I don't know the last time any of us have removed a rule from a firewall. But here's another example of that complexity. You now have multiple instances of controls inside an environment. And as a result, if traveling between one machine and another machine in a different segment, I hit 4 different firewalls. What is our firewall policy or our IPS policy? Well, it's the policy of every firewall that you hit and the order that you hit depending on the route that you took. And that becomes an intractably complicated problem. And as a result, we don't do it a lot. We have 2 issues here. One is an alignment issue. At its core is an architectural gap between what we're trying to protect and where we're trying to protect it from. We're trying to protect applications and data. We're trying to protect it from positions on endpoints, servers, and network links. The policies are about applications and data. The controls are sitting on compute and network. And furthermore, that generates not just the ability, once infiltration occurs, to easily propagate and move with freedom of movement inside. It creates a problem that inside that environment is so complex, there's very little black and white. There's very little known good and known bad inside that environment. There's a lot of gray. And that massive amount of gray is incredibly difficult to sift through, particularly under attack scenarios. And that ultimately can be, you see that borne out in the numbers. I've often commented on this before, that the growth in security spend over the last decade has been double the growth in IT spend. And the only thing growing faster than security spend is security losses, which last year, according to one study, surpassed the drug trafficking to reach about $600 billion globally. Something is amiss, and it's not the lack of innovative security products. There are a tremendous number of innovative security products. I see them as I walk across the floor here. It's not a lack of funding. We all wish we had more funding, but the amount of funding in the venture capital community, the amount of spend by enterprises is at record levels. Something is more fundamentally at play here, and I would submit that at the core is an architectural issue. My thesis here is that we need to do 2 things. We need to better align controls and policies to applications. And the second is that we need to go back to a fundamental principle of cyber hygiene, and that is the principle of least privilege. Now, for those of you familiar with the principle of least privilege, it's nothing new. In fact, to my knowledge, the first publication that sort of referenced this was Professor Salzer at MIT, and this is in the early 70s. They're very simple, and it's basically need to know. It's ultimately every program, every privilege of user basically should operate using the least amount of privilege necessary to get the job done. And the benefits of least privilege are multiple. I mean, it's certainly a smaller attack surface. It's certainly a better signal-to-noise ratio. It introduces much more actionability, understanding what sort of your options are to do when that. And it's more than just blocking. Least privilege isn't just about blocking stuff. In fact, if you consider in a kill chain, in a typical kill chain, and you look specifically at the middle of that kill chain as we move through propagation and extraction, there are ultimately 3 planes of attack. One plane of attack is horizontal. It's across the network. And basically, if I can move from my position to a target through one or multiple hops across systems in the network, I can move laterally. That is a horizontal attack plane. There's a bottom-up attack plane through the data plane where you basically go after things like misconfigured or open switch ports or vulnerable, some things that are vulnerable in the physical underlay. And from those positions, I have the ability to sniff data, spoof machines, etc. There's a third attack plane, which has come top-down, to come in through the application. And many attacks, and I have lived through some, deploy mixtures of these. Now, as you consider applying a least privilege policy to the various layers of the attack, you will notice that the expression of least privilege policy as you move through these planes moves from things that are relatively granular and static to things that are much more dynamic and fine-grained. As you move into the application and consider things like what processes should run and how processes should interact, you start to get into very fine-grained things and things that are more dynamic. And so we should be thinking, if we're going to deploy some approach to least privilege, it too should have a range that isn't just about blocking, but is also about monitoring, detecting and responding, and it can provide us with an enormous benefit. And it moves us from a model that is today predominantly focused on bad, on understanding and identifying bad. Now, I'm not suggesting that that is a bad model, pardon the pun. Ultimately, we do have to understand threat. The problem is that is, in the absence of something else, that's a massive problem. It's constantly changing. It's often non-deterministic, very difficult to always identify things in real time, in line, difficult to identify these things from a singular point. It's difficult to protect your position in many cases from that. It's hard to trust the thing you're trying to use to enforce. And the response often is manual and unorchestrated. There's a lot of difficulty in this model on its own. We need to go back and introduce another element to this model, which is focus on good, understanding your child, understanding your critical application. That allows us to really establish least privilege environments, create a simpler, smaller problem that we're focusing on, much better signal to noise, much better actionability. When you understand intended behavior, when you understand actual behavior, when you understand the controls and the topology, you have much greater actionability for this. We have to start introducing more of a model like this if we're going to start getting ahead of this problem. Well, great. It sounds great. It's hard for anyone to argue against the benefits of least privilege. Why don't we do it? And we don't for largely these reasons. I don't understand my applications. I don't know the last guy who worked here who understood our applications. I don't understand how our applications interact with our infrastructure and what controls are placed where. And by the way, if I understood any of that, it would only be valid for a very short period of time because there's so much change that's constantly going on. And guess what? There's a little big stakes here. If I get this wrong, at best, I've introduced a whole new amount of complexity, and at worst, I'm creating a whole bunch of disruption on critical applications. And those are all valid concerns. All right. What on earth does this have to do with virtualization in cloud? It's funny to me that whenever we have conversations about cloud or virtualization, we talk about all the unique properties that this provides and how we might benefit from leveraging that in how we create applications and deliver services and scale, except when we talk about security. And then the conversation is, okay, how do we secure this thing? Now, I'm not suggesting that isn't an important question. I'm just suggesting what happened to the question about all these unique properties and how we might leverage them to do a fundamentally different thing. If we're innovating in other areas, why can't we innovate on this area? See, the thing about virtualization, which is really the fabric of the cloud, private or public, is we now have this abstraction layer, this relatively ubiquitous abstraction layer that sits in between the physical infrastructure and the applications that are sitting above it. And that provides a really interesting position that provides, in my mind, 5 very unique properties. And the first is you're actually in a pretty good position to understand applications. You're in a position to understand the intended state of applications because you're seeing all the provisioning events and what is leading to the composition of this service in the first place. And you're in the position to see the run state. You're actually in a position to see the compute stack, the network. Second property is topology. You're actually, in one of the first times, you're in a position to understand the complete topology of the network and where your controls and how they're placed and what's sitting upstream from me, and therefore what are the things that I might avail myself of. The third is alignment. Think of it as a translation layer, a map between the applications and the infrastructure it's running on. And in fact, for it to do its job, it actually has to maintain that map in real time all the time. We can use that. to actually have a model that says we create, for example, logical boundaries, and as dynamics and things move, the boundaries move with it. And those get to the heart of the three questions that I brought up, but there's more. There's two more that I think are worth mentioning. And one is, once you have an infrastructure that's all built out of software, you have the ability to rethink the automation model. We now have the ability to quarantine a machine, kill a machine, bring up a gold image, insert full packet capture, encrypt a network. So many things are now at our disposal to really leverage the infrastructure itself as a ubiquitous, very flexible control with a high degree of automation. Now that comes with a caveat. And that caveat is about the difference between doing security in software and in hardware. The challenge of doing security in software is that you're sitting in the same trust domain as the attacker. You're sitting there and you're running in the guest. And that means that you're exposed, you're addressable from the direct attack surface. You can be turned off, you can be manipulated, and this happens all the time. The beauty of it is you have the best context because you can see the users, the application, how it's changing in the configuration. Now, the hardware, doing security in hardware is the opposite. You're actually in a separate trust domain. And that's beautiful because now I can trust my position. It doesn't mean that any of these hardware appliances can't be compromised. There are millions of lines of code too. But they're sitting in a separate trust domain. If I own the machine, I can't just move laterally. I actually have a separate attack that I have to wage against that separate device. The problem is you lack any context. I have to reverse engineer any context I want to get, which is why the whole next-gen firewall market sort of emerged. I'm going to reverse engineer what application this is, et cetera. But with the virtualization layer, we actually have not just the guest, we have the host, we have the kernel, we have the actual layer underneath, which actually is running in separate parts of the processor and the memory. These boundaries are enforced, reinforced by hardware primitives in the Intel chipset. I would submit that we actually have a separate trust domain from which we can do security. And I don't mean from the guest, I mean in from the compute stack. And that provides something very interesting. Now, by the way, I'm not suggesting any software can be hacked. I'm just suggesting that this isn't simply moving laterally from one to the other. This is actually a separate hack, much like we've done with hardware before it. So these are the interesting properties to kind of work with. And the question is, can we leverage these unique properties to think about how we rethink securing critical applications? Now, just so that we're on the same page in terminology, I think we're all familiar with server virtualization, right? We virtualize the stack, we have the servers, we install these hypervisor, we can now create a series of multiple virtual machines on top of this. An important new dimension to this is network virtualization, and the way to think of it from a security perspective is this. Every virtual machine can't talk to anything else, virtual or otherwise, without first passing through a virtual switch on every one of those hypervisors, right? And so if we take control of all those virtual switches and create a uniform new control plane, we essentially have this, think of it as a network hypervisor. Now we have a singular uniform control plane from which we can say, this application is that machine, and that machine, and that machine, and that machine interacting in this way. I'm going to give it its own network. I'm going to give it its own address space, its own L2, its own L3. I'm going to give it a distributed firewall, so now it has one front door. I've just created a nursery. I've just created an enclosed space from which I can create least privilege, and I can align controls around that. And that's the central idea behind how things like network virtualization are being used. And if we go back to this notion of these three attack planes and start with the first one, the network and the horizontal attack plane, we're essentially going from a model of traditional segmentation to a model where we use this abstraction layer to create a logical boundary around this application. And now we have those unique properties of the front door of that nursery, right? One, we've limited a lot of lateral movement issues from something that doesn't have an address space on it. And we've created a single front door to that from which we have the ability to align controls. Now, this doesn't mean this is completely isolated. Of course it isn't. You can get access to Active Directory and DHCP. You have other shared services. You have users. The point is this. You now have a singular place from which to align these controls and to inspect things in context, whether they be access policy or analytics. This is, by the way, where it was driving probably the biggest percentage of adoption of network virtualization, this very thing. And this is not a small thing. VMware alone, I think, has approaching about 3,000 customers, just the majority of which driving from this kind of use case of micro-segmentation. If you hear micro-segmentation, what it really should be is a mixture of being able to create this isolated boundary and the ability to align controls around that boundary. But I want to give you some insight on where it goes from here. If we think about the data plane part of this, we're starting to think about, as I was mentioning earlier, things that could go after the physical underlay and use that position, right? From that position, for example, an exposed switch, I have the ability to sniff traffic, so I might see credentials. I might see data. I might see the structure of queries from an application to a database. And then I have the ability to spoof machines with impunity and be able to then execute attacks using those credentials, using that understanding of the query module. Right? Now, there are cryptographic means to address this problem. The problem with them is they're insanely complex, because you'd need to figure out and map these machines to their appropriate IP subnets and switch ports, and you'd need to set up point-to-point encryption tunnels between every possible communication pair, and you'd need to manage all of those keys, and that would break a whole bunch of network security products because they can no longer perform deep packet inspection, and no one's going to do this. But if you now have a uniform control plane, and encryption, for example, can be a distributed service, the notion of saying, I have a microsegment, I want it to be encrypted, and this being implemented in this control plane, the ability of encryption being a filter in the virtual switch, and every interaction between these machines, regardless of whether they're in the same cloud or the public cloud or wherever, nothing gets communicated between machines. They're authenticated, they're encrypted, they're integrity checked. That's suddenly a possibility, and it's insanely, insanely simple. And these are one of the things that we have been building that'll come out later this year, is this notion. We think it's going to change how people think about adopting public cloud, change how people think about addressing threats from, for example, rogue network admins. It may even change how people are thinking about some application encryption, which, by the way, does address a wider threat model than network encryption, for example. But this could be infinitely simple and do an 80-20 rule. I think there's going to be a lot of folks who are saying, I just can't afford to start just building this in everywhere. I can apply this and not only use this permanently, but in a response. Under attack, I have an actor in my environment, and I want to, as one of my actions, to start encrypting all of my critical segments. So I think it will start making people think differently of how they use cryptographic means to protect the integrity, particularly from bottom-up attacks. Now, let's go to the top, from the application. Now, this has been a real tricky one, but frankly, a huge one. If you think about how many attacks are executed from the application level, it's pretty substantial. So the question is, where can least privilege apply from there? Now we're getting into more fine-grained dynamic things, and it starts to push us more into detection and response than just sitting there permanently blocking. But the first problem we have to understand, again, is going back to how do we understand the intended state of that application in order to start developing a least privilege model that would work. Now, every part of that system that is an application is composed of little mini applications that have operating systems, they have processes. Some of those processes are communicating in or out. You might have security monitoring tools. And it's not just, don't think of this as whitelisting, which is just thinking about one machine. Think about a whitelist, in essence, for the application. A bunch of things that happen to interact in a certain way. So how do we understand the intended state? Well, it goes back to one of those first properties that I mentioned earlier, that the benefits of being able to see things from a virtual layer, one of the things you see is the intended state from things like infrastructure events, right? You're in a position to understand when someone is provisioning certain virtual machines and provisioning connections between machines. You're in a position to see the developer workflow who is provisioning elements onto that infrastructure, right? I might be using Maven or Ansible or Jenkins or some various mechanisms to deploy elements that are going to form this application. And I'm in a position to observe runtime behavior, whether it's at the staging area or in the early area, all of which give me a much more refined understanding of what is this application in ways that we simply couldn't. Simply couldn't before. Once we understand intentional state, then the interesting thing is creating a runtime attestation model. Something that in runtime can watch what's happening in the application compared to its intended state, to the manifest, to the birth certificate, going to my previous analogy, the birth certificate, not just of this machine, but of the application consisting of multiple machines. Now, it's not that attestation itself is so hard. The hard thing is the integrity of the manifest and the attestation. But if you recall earlier, one of the unique properties of virtualization is isolation. Not in the guest, but in the host, right? I've talked in the past of the virtualization potentially being the Goldilocks zone of security. And in fact, this project I'm referring to is codenamed Project Goldilocks. The idea is going back to what I was saying earlier. Security in hardware is great isolation, but very little context. Software is the opposite. But we have the ability to start creating controls that are inside the hypervisor kernel or leverage functionality in the kernel to have really a separate trust domain to maintain the protection and integrity of the controls themselves. And so the notion of leveraging that to create a virtual enclave to protect the manifest and the attestation service, but still have visibility into the guest and the ability to see in real time at load and at runtime what's happening compared to what was intended by the application team, creates a very, very different model. Creates a very bright signal with a lot of context. The last part of this is how do we respond? How do we remediate? And that goes to another property that I showed earlier, which is automation. The ability to say, I can create libraries of runtime response routines for quarantine and for killing a machine and bringing up a gold image, inserting full packet capture and encrypting critical segments, snapshotting the machine for forensics. Suddenly you have a wealth of library of routines and a potentially common policy namespace for those. And so the idea here that we have been working on for the last year and a half, and that we'll be coming out with something this summer actually around this, that's going to be one of the most exciting things we come out with, is really around this model of being able to have a least privilege sort of attestation model for critical applications and to be able to monitor that and to give tools to the SOC, to the security architects in the SOC, that they can have windows into the virtual infrastructure to leverage this as very bright signals and to be able to respond. Again, it's about a cyber hygiene model based on least privilege that extends from the data plane through the network through the application. And this doesn't just apply as its own. It doesn't just benefit practitioners, it benefits the security vendors on that show floor. Because we'll be providing access to these things to them too, so they can see the manifest, so they can see the intentional state, so they can see the run state, so they can also leverage these response routines. We're very excited about this. It's quite new concept. And if anyone, by the way, is interested, I do actually have some of the development team here who's working on it, and we'd be glad and afterwards take questions on it. And in fact, we're just starting beta, and if folks are interested, there are some slots open for that as well. So be glad to entertain that. So, you started with this stack, the security stack, which today is plugging into servers and networks. What we're trying to do here is leverage the fabric of the cloud in order to align controls around the applications we're ultimately trying to protect, and then to leverage that fabric to create a least privilege model that extends from prevention all the way to detection and response. And we think this could turn the tide, right? We think that a lot of this is about simplifying this picture to be saying that if things are getting inside, that massive gray can be shrunk down by taking a positive model that understands the critical applications, that sets up least privilege model, that allows us to align controls really to what we're protecting and have a smaller problem we're solving. I always find it ironic in the space race when we hear that old story how, in the US we were developing very sophisticated technology to have pens that write in space, and the Russians brought pencils. Sometimes simpler solutions are staring at us in the face, and shrinking the problem allows us to start with a smaller problem to begin with. That's why I often say it's a completely valid thing to say, how do we secure virtualization? But we'd be missing an opportunity if we weren't asking the question of how do we use virtualization and how can we use cloud to secure things? We're doing this in every other endeavor. We have to ask the same question here. We have opportunities to change the model. So the question is, what will you deliver next? And for the practitioners in the room, I urge you, get more educated on this if you're not already playing with this. And I don't even just mean with VMware technology, with whoever's technology, leveraging this and starting to look at how do we create least privilege models, how do we start leveraging the cloud, leveraging virtualization to secure things, would be a missed opportunity. We've never had the opportunity to have security architected in. We're always in a position where the applications are designed and the infrastructure is built, and then we're asked to secure it. And this is the first time we have the opportunity, irrespective of those things being in place, using an overlay to be architected in, to have a sensible architecture around security. If we don't snatch this, we're missing an enormous opportunity. And there are plenty of opportunities to get more educated. There's actually a new book by Wade Smith. I think I actually just saw Wade in the audience, is over there on micro-segmentation. I think Wade's book is actually available in the VMware booth and will be available online. There is, go to the booth, you can actually learn more. We have stuff on our website. I'm starting to create a dialogue online about this topic. There's plenty of opportunities. I urge you to. And to the vendors in the audience, I urge you to start thinking about how you could rethink your controls by leveraging this. If you could be a distributed service, if you could leverage remediation, if you could get access to this context, how could you rethink and not just extend your current model and use the cloud as one more operating environment? So, and to the cloud infrastructure and folks like us, I think it behooves us to really open this thing up. And we are investing heavily in this topic and heavily in this technology. We firmly believe that while we're not a security company, if we can do our job right here, we might just become the most important company in security by helping solve some of these fundamental architectural issues and infrastructural issues. So John is going to come up here in a moment and talk about how this concept extends to the mobile fabric and to the user community. But so for those of you interested, please stick around. I think you'll enjoy that. And we're going to continue the dialogue online. I'm actually engaging a lot of online on Twitter with this topic as well. And as I mentioned earlier, a number of us are here in between in the break, and we'd be happy to talk with folks. And if folks want to ask questions or get more involved on things like beta testing of new things, happy to discuss. Thank you so much.